let's go right into it. What's the goal that we have today? Basically, we want to be able to use Google Glass to stream information of its sensor data to the computer, and then from the computer send the commands to the ARDrone so we can pilot it. We're going to discuss more on the architecture in a few minutes, but just to give you an overview of what we're trying to accomplish and why, I'll talk later why I did it that way. So let's start by giving some specifications to Google Glass. Google Glass is actually an Android device, runs on top of the Android operating system. It has an ARM processor. It has a small but high-resolution display, which is equivalent to a 25-inch screen seen from 8 feet. It has a small camera, but it's capable of 5-megapixel pictures, to take 5-megapixel pictures and also record video at high definition at 720p. How does it interact with the external world? You have two main ways. It has a Wi-Fi adapter, so you can connect to other devices to Wi-Fi, and it also has Bluetooth. 16 gigabytes of storage, 12 of them are available to the end user, and it has a bunch of sensors inside, 3-axis gyroscope, accelerometer, and magnetometer, which is amazing for this size. As you can see, it's a little beast, all packed in this little device. What about the ARDrone, the quadcopter? The quadcopter also has a front camera, which is 720 high definition camera. It has 4 engines, and all of them are controlled by this microcontroller, which is also an ARM processor. It has down here ultrasound sensors to measure the distance from the ground. But the most important feature of this device is actually its capacity to receive information through wireless. If you're familiar with remote control toys, most of them are controlled using infrared signals or radio frequency signals, which makes it harder for us software engineers that are not familiar with those technologies to connect to this. So amazingly, this one has its own internal wireless network, which is private, which talks TCP and UDP, which we all can talk. We may not be able to program infrared or radio control, radio frequencies, but yes, we can do TCP and UDP. So that's the most important feature of this device from my perspective, at least for us. So now let's talk about the architecture. First of all, a disclaimer, I am not an Android developer, and that's why I did it in 2 portions. I'm not that much skilled in Android development. I learned a lot in this process. Steve helped me a lot too. So first of all, I wanted to be able to interact with the ARDrone, sending commands from my laptop first. And that's what I did. I used the wireless adapter of my computer to send information to the ARDrone, and I was able to do that successfully. The second portion of the architecture has to do with sending the sensor data from glass to the computer. Now, as I mentioned at the beginning of the talk, there are several ways to do that. One is through the Wi-Fi. The other one is through the USB port. I'm right now connected to it. But that means that I have to be attached to the computer. And the third one is Bluetooth. Why I use Bluetooth? More for practical reasons and another bunch of reasons. But if I wanted to connect through Wi-Fi, I couldn't do it without getting another adapter for my laptop, because I was already using the one that I had for connecting to the quadcopter. So either I bought a new one and configure it, so have 2 wireless adapters and then use that one, or find another means. I didn't want to be attached to the USB port because I wanted to be free. The reason why I'm attached now is so I can project the display, but otherwise everything works without the cable. So my only option, my last option, was Bluetooth, which I didn't know much about it, and I learned a bunch in the process. If you are an Android developer, you probably can tell me a few more reasons why Bluetooth may be better. One of the disadvantages of Bluetooth is that it doesn't have the same range of scope as Wi-Fi. it's shorter, but at the same time, it consumes less energy because of that. Another thing that you may not be aware of is when you start using Google Glass, you start realizing that it's a very different user interface. You don't have keyboard, you don't have mouse, you don't have even touch screen. So how do you connect this thing to the wireless? First, the wireless router, and then second, to a specific IP address. I mean, how do you even put the IP address of the place that you want to reach? So because of all those things, actually, Bluetooth ended up being a good solution for me. Why I divided it in two portions, like I said at the beginning, I was not familiar with Android. I wanted to try two different modules. It ended up working very good for me because I was able to test both modules independent of each other. So let's start by describing in more detail the right one, the first one, the right ones, which is the connection between the laptop and the quadcopter. So another excellent feature of this specific model, the Parrot, is that they offer an open source project that basically lays out for you the whole C language implementation on how to connect to these all low-level commands that you have to send it to make it fly. And that's great, but I wanted something more higher level because I didn't have much time to understand the C code, and it was like hundreds and hundreds and hundreds of lines. I was thinking there may be something easier to do that. So I was thinking it would be nice if there was a Python interface to be able to do the same thing that the C program, the open source project, was doing. And I was wondering maybe somebody already did it. So I went to the internet and I searched for that. Python ARDrone, and boom, the first thing that came out is this GitHub repository. This guy, Bastian Benthur, created this Python ARDrone library, and this is the way you use it. You import the library, you instantiate the ARDrone object, and you tell it take off and then land. Awesome. I wanted to see if it worked. So I clone it, download it, and start poking around with it. Let me show you how I use it. So if you go to my personal repos, not the company repos, but my personal, you can see here's the, by the way, here's the repo of all the code that I'm going to show you. Everything is there. You can install the prerequisites, everything that you need, and then you have the configuration, and finally the application. So you can try it at home if you have a quadcopter, or even if you don't have it, you can use already the code for the glass to make it work. So everything is there. This is my Python implementation on how to use the ARDrone library. It's extremely simple. It's let's see, 52 lines, basically a while loop, where I listen and I give written commands. If I wanted to take off, send take off, and tell it, okay, take off. Land to land, and it lands. And that's about it. I import the library and I use it. Let's see if it works. So let's go to my terminal. There it is. There's our ARDrone Commander. It's this one.
Should we take any protective measures?
Yes.
Or anything
Oh,
like
yeah, me.
Yes.
Yeah. Do we have helmets?
So I'm going to switch briefly to not share my computer, so you can see. I'm going to just. Oops.
Yeah, it's got styrofoam, right?
No. What did I do? Anyway, the cord is not. All right. I'm just going to. Sorry for the remote people. You can see it in the other one. I'm just going to connect the battery. Like I said, the battery doesn't last too long, so I have to charge it up to before the demo. So I'm just going to connect it very quickly. All right. right, it's alive. You need helmets. All right. Let me share my desktop. So we have that. Let me see if the wireless is connected. Yep, the wireless is ARDrone. That's the private network. So let's run the program. Okay, receiving commands. So let's go back to the source code. If I want to take off, I write takeoff, or T for short. If I want to land, C. So let's do just those two. Okay, here we go. All right, pulling up. There you go. So it works. Let's quit now.
Nice fan.
Yes. Nice fan. Where are we? All right. So that's the first portion of the solution. Let's talk about the second portion. So now we are able to connect from the computer to the ARDrone via wireless. So now I want to read the information, the sensor information from Google Glass, and send it through Bluetooth to the computer. So basically, the application, the Google Glass application, has two main components, two main portions to it. One is being able to connect the glass to another device through Bluetooth. Once the connection has been established, then I want to be able to send the sensor data through Bluetooth to the computer. So those are the two main things that I want to do. Now, as I was explaining earlier, we don't have a keyboard, we don't have a mouse, we don't have a touch screen. So you have to think about all these things on how you're going to use the device as an input device. How can you send the information, or how can you use the information that the Google Glass provides in order for you to pilot the ARDrone? So for me, I experimented different things. The ones that I found the most useful are basically getting the sensor information of the three-dimensional position of the device in respect to itself. And there are two things that I'm capturing: the pitch and the roll. The pitch is this movement, so it's over the z-axis, the movement, or however you want to understand it. Actually, it's not z, but over this plane, I'm moving here, and I have an angle of inclination. That's the pitch. This is the roll. When I move this way, left and right, this is the roll. You can also play with the yaw, which is this, which I didn't. I decided just to use the pitch and the roll. Now, for me, I want to be able to do this with the ARDrone. This is left, this is right, and I have forward and backward and up and down. I could use many different ways to do it, but the one that I experimented, the one that made more sense to me, is actually use the pitch for both up and down and forward, backward. So I have an elevation mode. With elevation mode, you see the button on the right. There's an elevation button. When that's on, this means up and this means down. When that's off, this means backward and this means forward. And this is just left and right, left and right. So that's the way it works. So now, let's see the application in the glass. Let me share this. All right, so you will see in the screen what I'm seeing in Google Glass. Right. Okay, this is the application, and it's not connected to anything yet. But look at the values, how they change. The pitch is right now at 0, so it's leveled. As I start moving up, it starts going up until it passes some threshold, which in this case is 15. And now look at the command. It says none first, so it's doing nothing. And then when it passes the threshold, it goes up. The same thing the other way around. I go down, 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 and there you go. Sends the command down. Then right and left. And if I click on the elevation button, then it's not up anymore, it's backward and forward. All right. So that's what I have with the application. I'm going to take a brief detour about flying the ARDrone. And because on Friday I have the cake and beer project, and unfortunately I was not able to finish. What I wanted to do then is use that information that I'm getting from Google Glass as an input device for a browser. Now, if you think about that, that's not trivial because of this. A browser doesn't have, it lives in a sandbox. It doesn't have access to the hardware of the computer. So you cannot access just without any further issues the information from Google Glass. So I had a way to communicate with the browser, sending the information that I'm capturing from Google Glass. So I started researching about that, and I had the opportunity to learn about some technologies. One was obviously the one that we use at iSpatial is WebSockets. So you could use a server, a local server that uses WebSockets to connect to the information that I'm sending to Google Glass. There's another technology which is not as well known. It's called server-side events. It's very similar to WebSockets in that you can contact a server. The difference is that this one is one-way communication. It's called push event information from the server. So you have a bunch of things that are receiving the server, and you push it towards the browser. You can send real-time information to the browser. So I decided to use that one just to learn and see how it works. So I developed, let's see, a small server that does that. And I connected it to iSpatial. So let's see, what do we need here? Okay. This server is going to start listening on the Bluetooth serial port, and it's going to capture the information for this. At the same time, the server is going to start pushing the events towards its port. On the other hand, the browser is going to register to the server using server-side events. It's going to get information from it, and then it can act iSpatial to move Google Earth according to my movements in the head. So that was my project. I didn't finish. So this is the server. I'm going to start listening, and now I'm going to connect. Oh, let's first. I have to actually install it in iSpatial. I'm not going to program iSpatial, so don't worry. I'm just going to patch it on the fly. So just to give you a taste on how easy it is to use server-side events, look at the last two lines that are not commented. The event source is how I tell, okay, I want to connect to this server. And once I do that, I just add a listener, a regular listener, and I pass it a callback, which is the move camera. That listener starts listening for the events that happen in the server. And all of this doesn't require any other protocol than HTTP. I don't need atmosphere or anything. That's all I need, those two lines. And then we will start receiving the information. What does the callback do? Basically, the callback, as you will imagine, it captures the information, and according to the commands that I have already for my drone, I'm just going to start changing the camera view, the look at of the Earth. So let me copy all of this, paste it in my iSpatial console. Let's see. All right. So now I'm going to go to my glass.
What does that do? Does that inject that code into the running iSpatial browser instance?
What it does is you're running iSpatial into the JavaScript virtual machine, if you want to call it, and then I inject a listener of these events, and the callback uses the iSpatial instance to control this. So now I'm going to connect. This is the Bluetooth. This is the Bluetooth module. So right now I'm connecting to Bluetooth, and oops, that was the wrong one. So it's going to fail. Sorry. Okay, let's try again. That's it. Jose Troche's MacBook Pro. So let's try again. All right, now it's connected. So as you can see here, the server kicked off, and it's telling me that it has one client, and the client is my iSpatial. So let's close this. This was failing because the server was not up. And now I'm going to go left, moves left, right, moves right, up, goes up, down, goes down. Awesome. So that was the detour that I wanted to show
When
you.
you pasted it into the developer console.
What's that?
That's injecting that JavaScript into the
Yeah, into the environment
developer
that
console.
It's like JavaScript.
I didn't know you could do that.
Well, because JavaScript's all client side,
Okay.
so you're just doing it for that browser.
yeah, just for that browser. So if we wanted to persist it, we just add that code into our regular code, and it will work. So you can take these to GeoInt if you want.
Ooh.
That'd be cool. All right, that was the detour. Let's go back to the demo. So now we know that we can send this information through Bluetooth to the computer. We know that we can read it there. So now we have to integrate these two. So on one hand, I have a module that sends the information from the computer to the drone. And then on the left side, we have the Google Glass application that sends the information to the Bluetooth serial port. So tell me, how do I match them both? The way I'm listening to the information from Glass is, if you saw the command, sorry I didn't explain this very well, but basically I was thinking, okay, how can I install a Bluetooth device in my computer? I have to implement it somehow so they both can pair. So I'm saying this is the other Bluetooth device and the Google Glass is the other one, so how do I pair them? So it ended up being easier than what I thought, because it's just one-way communication. I'm sending from Google Glass the information, and the computer just can listen a regular, it's like a serial port. And the way I read it is I cat it. I said, this is my standard input, redirected to the serial port, and show me what it's doing. That's what it's doing. So I have that part. I don't have anything installed in my computer except for listening to that. So how do I do it? I type it. So I get information from Google Glass, and I type it to my other command. So that's what we're going to do. I think we're ready. So let's see. Clear this out. Oops. So this is the serial port. I'm redirecting the serial port, and I'm sending it to CAT, so I can pipe it to the other one, which is the ARDrone. All right. Let's kick it off. It's listening. Let's go now to Google Glass. Okay. It's connected to my computer through Bluetooth. Sometimes it doesn't connect the first time, but let's see. Let's try one more time. All right, it's connected. So the terminal is receiving the commands right now. Let me check that we have these. All right. We have the wireless connection. So let's see. I'm going to click the takeoff.
There.
Forward. I didn't think that it was going to be that crowded, so sorry I cannot manage. If it goes too closer to you, just put your hands, okay? So left, right, okay. That's it.